Okay,
Yep.
terrific. Great. All right, great. So yeah, we're going to talk a little bit about exactly what Mike talked about. That is creating a centralized integration hub for your IBMI to make sure that you can connect to the things you want to be able to connect to, and that the people who need to connect to you and who you want to allow to connect to you can do that, and can do that easily, but also securely and in a highly performant way. So we'll talk a little bit about that. We'll talk a little bit about what is a central integration hub. So what exactly does that mean when we talk about that? And then we're going to talk about security, because if you are going to start to open up your IBM i2 connections, even within your own organization, of talking to your, your Windows servers or your Linux servers, you want to know that those connections are going to be secure. So we'll talk a little bit about security. And then we'll talk about performance, because what we're finding is a lot of people are starting to add these kind of API calls to their existing IBMI applications. And if you're in the middle of an RPG business process and you need to call out to something, you don't want that to slow down your business process. You want to make sure that you're getting top performance out of these APIs. Or if you start to open up your system to people connecting in, you might find that a lot of people want to take advantage of that, and you start getting very, very high volumes of requests. So you want to make sure your system is set up to handle whatever volume requirements you might have. And then we'll talk a little bit about, well, how can you start creating these APIs? How can you generate APIs to your system so that you can use that central integration hub, so you can have a way of providing access. And then we'll talk about monitoring and managing things, because again, if you're letting people in, you want to be able to keep track of who's coming in, what it is they're doing, and are they getting the performance you want them to get? Are they getting the data that they need? And then we're going to talk a little bit about open source and some of the value that you can get from using open source as part of your application stack. Talk a little bit about how it can help increase the productivity of your development efforts, and how a central integration hub actually enables you to take advantage of open source. And then we'll talk a little bit about managing that environment. So again, once you create this environment where you're using open source along with your IBMI stuff, you need to be able to manage the development. So you need to have some kind of a DevOps environment for managing all the things that you're doing. So a lot of things to cover. Let me get into it. And by the way, Aaron is going to be also involved in showing you some of this stuff and in demonstrating some of the things that we're doing. And at the end, we should leave some time for questions, so that if you have questions about what we're talking about, we can answer that. And he's a lot smarter than I am, so he'll probably get involved at that point. So just real quickly, for those of you who are sort of not watching what's happening with this whole idea of connecting things together, it's a really huge move in IT in general, that companies are connecting. Whatever industry you're in, whatever kind of business you're doing, we're seeing just very, very rapid adoption of connectivity kind of technologies, and usually via these application programming interfaces. API is really a very generic term for anything that allows you to connect things. And the number of APIs and the amount of API traffic is growing very, very, very rapidly. So in that case, if you want to play in that world, you need to have some way of managing that traffic. So if you're going to say, okay, I'm going to start doing some of these things, I need to have some way of creating that access and then managing that access. And there are lots and lots of reasons why people do this. So these are just some of the use cases that we've worked with customers on. So some things to think about. If you're thinking about, gee, how am I going to continue to move my IBMI forward? What kinds of things might I do? So, for example, we have lots of customers that are doing new modern user interfaces where they say, okay, I want to build a user interface in JavaScript, or I want to build a user interface in PHP, or I want to build a user interface in Python, but it needs to interact with my IBMI. And Python, JavaScript, .NET, that's not something they sort of do naturally, because the IBMI works a little bit differently than how they work. So if I want to be able to expose things, I need to create some kind of an interface that allows them to talk. And this is just an example here of a customer. This was a mortgage company that had a kind of typical green screen kind of an application where you can see they've got lots and lots of fields stuffed onto the green screen, and they wanted to have a better user interface. So we worked with them on an interface like this, which is a React JavaScript application that instead of having function keys for navigating between screens, they have these tab views. They can send the data via email out to the customer. They can export it to a PDF. They can have these infinite scrolling lists where they can see lots and lots of data on the screen, and they can have multiples of those on a single screen, and they can put images on the screen, and they can have shortcut keys so they don't have to go through a bunch of menus. So just a new way of presenting the data. The underlying RPG code, the application code stays the same because RPG is really, really good at doing core business processing, at doing transaction processing. So there's no reason that you need to take things out of RPG as far as the core business goes. But what React is really good at, or JavaScript is really good at, is user interfaces. So you're basically using the right tool for the job in order to modernize or move the system forward. So that's one use case of creating those kinds of APIs. Another thing we see are people who want to add new capabilities via some external provider. So somebody provides a function out on the web, and you want to be able to use that from your IBMI. One of the most common ones we see out there is messaging. So I want to be able to send text messages, order acknowledgements or shipping notifications. I want to be able to send some kind of a text message, payment reminders directly from my RPG application. And so you can create that kind of an interface where you talk to like Twilio being a text messaging service where you just send them the phone number of the person you want to send the text message to, and they take care of all the infrastructure of sending out those text messages and then gathering responses and sending them back to you. So you can talk to that external provider right from your IBMI. Or if you want to talk to, Amazon or Shopify, or you've got some kind of an e-commerce site that you want to talk to. Again, the integration hub can provide an easy way to talk to those things. Or if you need to talk to your shipping providers, or you want to talk to payment providers, or if you are a payment provider, you want to create those kinds of interfaces, you can do that through an integration hub. Another thing that we see a lot of is that people want to provide a better user experience for their customers and partners. So for example, this was a customer we worked with where they wanted their customers to be able to go in from a mobile device to look up their orders and then track the shipment location of their order. So basically, they gave them this mobile app that would go to the IBMI and pick up the orders for that customer. So based on the customer, it would give them just their orders, and then they could hit this track shipment button, which would then show them the current location of that order. So it actually brought back a map and a ETA for when that shipment was going to arrive, so that they could have the warehouse people at the loading dock at the right time to get the order. And then we also see a lot of people who need to integrate applications across platforms. So they've got multiple applications running. So maybe you've got some Windows applications. You've got maybe an e-commerce site that you've built on a Linux server or on Linux servers, or you need to talk to an Amazon or a Magento or a Shopify. So you can create that kind of integration where you've got the e-commerce site, which talks, sort of open source, and you've got your back-end systems, maybe JD Edwards, or it's Lawson, or one of the IBMI kinds of applications, and you want to be able to make those things talk to each other. So again, you can use the integration hub to do those kinds of connections between different types of applications running on different platforms. If you want to get out to a SQL Server database and get data, you can do that. And then you can use the modern languages. So if you want to, you can say, you know what? I want to start taking advantage of modern languages because that gives me access then to the millions, literally millions of developers who know languages like .NET and JavaScript and Python. So I want to be able to add that to the things that I do. So the next enhancement that I make to my application, kind of make it in RPG, maybe I make it in Python or make it in JavaScript. So what you can do is you can then create that kind of connection, so you can do JavaScript kinds of applications or Python applications that talk to your IBMI. So you have the ability to say, I want to use the latest technology for building this. And IBM continues to add new languages that you can use for extending your IBMI applications. Or again, if you want to talk to different databases, maybe you want to combine data from multiple different databases and create visualizations of data that cross platforms. Again, you can share that data. So through your integration hub, you can go grab data from multiple data sources and then integrate it into a shared kind of a dashboard. And then if you really want to do some very, very high speed kind of processing, or you want to talk to people like Amazon, you might want to use one of these message broker technologies where you publish messages from your application to the message broker, and then you identify who are people you will allow to subscribe to those messages, and those people can get the messages. So and I'm going to talk a lot more detail about how this works in just a minute, but this allows you to use the most modern technology for sharing data in a what's called a public pub sub environment where you're publishing and you have subscribers to your messages. So anyway, those are just some of the things that we've worked with IBMI users to. Now, all of those integrations share many common characteristics, and that is if they're going to talk to your IBMI or you're going to talk to them from your IBMI, you need to be able to do a secure handshake. So you need to be able to make sure that you can do the connection securely and talk securely across those environments. And you need to be able to transform the data from the way the IBMI deals with data versus how the open source world works with data. Because in the open source world, they don't work with data in the same way. Typically, the data you get from a web application or the data you get from other systems is going to be unstructured data. It's going to be data that comes in formats like JSON or XML, or maybe you get comma delimited files or null terminated strings. You get basically unstructured data. The IBMI wants very structured data. It wants to know that what you're getting is not just a number, but it is a number that's 10 characters long with 3 characters of precision. It's a packed decimal field or a zone decimal field. It needs to know that information. So as data comes in and as it goes out, you need to be able to transform between those formats, and you need to be able to do that very, very rapidly. So you need to secure the connection, you need to be able to do the transformation, and you need to be able to route all the connections that are coming in to the right place. So common functions of all these different use cases, and you need to have all that done. And that's, again, the point of that central integration hub is so that all of those functions can be performed regardless of what the use case might be. So let's talk a little bit more about security, because it's really important to ensure that those connections are secure, that you're being very careful who gets in and what it is that they're allowed to do. And one of the reasons you do that is because if you start using APIs, you start opening up the system, you've got to be really careful about who gets in, because API attacks are one of the most common kinds of attacks on systems today. People are really trying to get into systems via these APIs, because APIs are really powerful. They're great for sharing data and for sharing functions across organizations and for automating operations. But of course, they are a doorway into your system. So you want to make sure that they're secure. And one of the things that a lot of people overlook, and I've a lot of IBMI users who say, well, we're fine because our IBMI is not directly connected to the internet. The problem is that if you have any machines on your network that are connected to the internet, you can be victimized by an insider attack where somebody gets at your IBMI from a compromised machine that's inside your network. So even though the IBMI itself is not connected, the machines on your network are connected, and they may go in and initiate an attack on your IBMI. So you want to be really careful about every connection that's coming into your IBMI.
Right. And Dan, if I can just jump in and just add one thing on that. One of the things that we're seeing a lot with the companies that we're working with is the adoption of zero trust policies in their networks. One of the things that we're seeing is policies come out saying across the organization, all communication, whether it's between Windows machines and the IBMI on our network, whether it's just between your PC and the IBMI while you're on the VPN and where you're in the company building, that everything has to be secured, everything has to be encrypted. Every user has to be authenticated, regardless of where they're coming from and where their machine is for exactly that reason.
Right. Exactly. It's so, so one of the things you can actually do with that central integration hub is actually implement multi-party authenticate or multi-factor authentication for any access. So you can actually say from the terminal emulator, you can key in your IBMI username and password, but before you can actually get to the IBMI, it's going to send a message to your phone, which you have to respond to before it'll actually give you even that 5250 access to the IBMI. So if you want to, you can use that central integration hub for controlling every connection into your IBMI. So let's talk just a quick overview of security. We actually have a security presentation where we go into a lot more detail about this, but just some of the basics of security. Probably everybody has heard of SSL and TLS. SSL is kind of the old version. It's got lots of vulnerabilities, so it's been deprecated. So most people have moved to TLS, which is called transport layer security. So just so you know what it's designed to do. So the idea is that you want to make sure that no one has read your messages. So as you're sending messages back and forth, you want to make sure that nobody can see them. So like credentials, you want to make sure nobody's seeing any of that information. You want to make sure that nobody has tampered with your message. So nobody has changed the message, put in malicious code into your message, or done anything to tamper with the message. And you want to make sure the user is who they say they are. For those of you who are Marvel fans, you want to make sure that they are who they say they are and that they're not spoofing some other user. And so to do those things, you implement several different technologies inside that central integration hub. So TLS being the basics, that's the sort of communication layer where you are encrypting all the communication. So no one can read your messages that are going through, only the sender and the receiver, the appropriate people who are involved can actually read your messages. And then you can use things like JSON web tokens to make sure that nobody's tampered with your message, because every message gets a signature that is built from the message itself. So if the message has been tampered with, the signature will change and the system will reject it and say, no, this message has been tampered with. And if you want to go to that next level of ensuring that this user is who they say they are, you can use something like OAuth2 to go out and do third-party verification to say, tell me that this is the person they say they are. And this is where you see things like sign on with Google or sign on with Facebook. The system is going out to those providers to say, can you verify that this person is who they say they are? So what we find in a lot of IBM shops is a lot of IBMI users are API enabling their IBMI, and yet they're doing it using basic authentication, which means you're sending in IBMI user IDs and passwords with your API call, meaning you're giving people native access to the IBMI. So it's something that you can use, but there are a lot of risks to using it, because every time you send a credential up and down the wire, it could be discovered. And once it's discovered, somebody can use it. If you don't want to make the user keep re-signing on, you've got to store those credentials somewhere. That's another place that those credentials can get discovered. And you're giving that native access to your IBMI. So the modern way of doing things is really to use encrypted token-based authentication, where you're not sending IBMI native credentials, somebody signing on with their email address and a password or some made-up user ID. So they sign in with that, and then they get back an encrypted token. And then from then on, all that's getting sent back and forth are the encrypted tokens. So even if somebody can intercept it, all they get is an encrypted token that they can't read. So the idea is as you're constantly communicating, it's all being done with those encrypted tokens. And maybe you're doing OAuth to verify again that the user who signed in is who they say they are. And this is so you know what transport layer security means. These are kind of the layers of the internet. There's the actual hardware layer, the actual devices. There's the IP addressing, so all of the IP routing. And then there's the transport layer, that is where you're actually sending data, you're sending information back and forth. And so TLS is implemented. So this security layer is implemented here at this transport layer. So at that layer of the internet. So it's not down at the hardware level, it's down here at the transport layer. That's why it's called TLS. It's transport layer security. So if you want to use JSON Web Tokens, this is basically what a JSON Web Token is. So a JSON Web Token is something that has a header that identifies, hey, I'm a JSON Web Token, and this is the cipher suite that I'm using. This is the encryption suite I'm using. And then it has the actual encrypted payload. So what's the message you're actually sending, the information you're sending. And then it has this signature, the signature that I talked about earlier that says that this is a hash of the message. And if somebody changes the message, this signature will change. And so the receiver will know that the message has been tampered with. So you have a way, it's a container for your messages to make sure that they're secure and that they haven't been tampered with. And for OAuth, this is basically the OAuth flow of how things work for OAuth. So somebody signs in, that sign-in goes directly to some third party, in this case, Google, but that could, again, be Facebook, it could be Okta. There are lots and lots of providers that do this. They then get back a message, a token that says, yes, this is an okay user. That goes to the client. The client then sends that to you. You then go and check with Google or OAuth or Okta or whoever your provider is to say, is this a valid token? And they say, yes, it is. And then you actually start your communication session with the client. So it's a way of involving that third party to say, yes, this user is who they say they are. So that's just a quick introduction to security. Like I say, we have another presentation where we go into a real deep dive around security. So now let's take a look at performance, because what we're finding is more and more IBMI users are concerned with response time, making sure that we're responding very, very quickly if we're integrating with other people, and they need to be able to handle large volumes of requests. So there are lots and lots of things you can do to make sure that you are providing the top performance. So one is to run your central integration hub on your IBMI. If you run it on your IBMI, then it has direct access to all your IBMI resources, to the tables and views and logical files and physical files and programs and CL commands and stored procedures. It has native access, which can be very, very fast. But if you don't want to hook your IBMI directly up to the internet, you can run your central integration hub on Linux servers or Windows servers that are attached to your IBMI. But then you want to make sure that they have high-speed connections to your IBMI, so you're not getting slowed down by the latency in the line between the two systems. But there's an advantage of using those Windows Linux servers in that you can horizontally scale. So if you have a large volume coming in, you can horizontally scale. You can add as many servers as you want to handle the incoming traffic. So you can handle very large volumes of traffic. And when I say large volumes, I'm talking about thousands and thousands of transactions a second if you need to be able to do that. So you can handle very, 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 very high volumes of transactions. And the central integration hub will do all your load balancing. So as that traffic comes in, it'll make sure it's balancing the load across your many, many servers. And then you just simply open up a port in the IBMI to those systems, and you make it so that the only systems that can talk to your IBMI through that are those systems that you've identified. So you can keep that very, very secure. The other thing that's important in ensuring high performance is doing the job, doing the right tasks in the right place. And one of those jobs is to do the transformation of data from your JSON, XML, your non-IBMI formats into the IBMI formats. And you want to do that in tools that are really good at that. And probably the best place to do that is in JavaScript. It's really designed to do that. And it can do those transformations very, very fast. We've done some benchmarking where we found that we can transform JavaScript data into IBMI data about 20,000 times faster in JavaScript than it can be done using the tools in RPG. So you can do things very, very fast if you're using the right tools for doing those kinds of transformations. So a lot of things you can do to ensure that these connections are very, very fast. And the idea is you're using the right tool for the job in each part of the process. So, RPG, great, COBOL, IBMI native languages are great for your core business processing, and that's really where you want to do it. in doing things like data transformations and authentication and things that are really done well in languages like JavaScript, like Python, like .NET, those kinds of PHP, those kinds of languages. And that's really in line with IBM's sort of direction for the IBM I, which is they want the IBM I to be this sort of blended environment. This is a slide I took from Steve Will, who's the chief architect of the IBM I, and he says the future of development on the IBM I is this blended environment where you're doing development in multiple technologies and multiple languages using your IBM I. So again, ideas doing the appropriate things in the right place. So this is a typical central integration hub architecture where the core business functions being performed on the IBM I, and then as people are calling in all the connectivity, the routing, the authentication, the data translations, the functional authorization, all that's done in a JavaScript layer. And same thing when you're calling out from the IBM I, all the business functions on the IBM I, and then in the intermediate layer, you do all the transformations and connectivity in JavaScript. Now, if you want even higher performance, if you really have large volumes of data that you're managing or large volumes of messages, you can use things like Kafka. And Kafka is just one example of an event-driven pub subsystem for handling large volumes. And when I say large volumes, here I'm really talking about very high volumes. So just to give you a sense, Kafka was developed by the people at LinkedIn, and they're handling through their Kafka clusters, they're handling around 7 trillion, that's trillion with a T, messages every day. So it's very, very, you can get to very, very high volumes with Kafka messaging. So if you're looking at handling thousands and thousands of transactions a second, if you have those kinds of volumes, and we've actually worked with a couple of customers recently that are looking at 50,000, 80,000 transactions a second for their IBM I, this is the kind of technology you want to look at. So now Apache Kafka is a high-performance, resilient, open-source-based, event-driven streaming pub sub messaging application. So let's talk a little bit about what that means. So basically, Kafka is a broker between publishers of messages and subscribers to messages. So basically, the idea is that if I'm a publisher, I can simply say, I have some data. Maybe it's an order or an order inquiry or a payment from a customer. I have information that I want to publish out that a lot of other applications are interested in, that a lot of other applications might use. So rather than writing custom integrations for each application, I simply publish the message to the Kafka broker, and then the applications that need it subscribe to those messages. So when the messages hit the broker, they get notified, and either they get the message pushed to them, or they can pull the message down from the Kafka broker and use it as they're ready to. So it's a loosely coupled environment where I, as the producer, don't care about the consumers, and the consumers don't care about me. They can be working at their speed. I can be working at my speed. I can change my system. They can change their system. All that matters is that we're maintaining the contract that I'm publishing data in this format and they're consuming data in that format. And then what you have is you have what's called a topic in Kafka, which is basically just a list of the messages. So it's an ordered list. As the messages get published, they go to the topic, and the subscribers can subscribe to the topic to get those messages. So topics are just lists of related messages. So, a topic is just, a bunch of messages about the same thing. So here's just an example. If I'm in the medical environment, I might be publishing my patient's wearable device might be publishing blood pressure readings or other information that I want to consume. So it publishes these messages, and I, as the healthcare provider, I subscribe to that and I get their messages. Or this is another one from logistics, if I'm tracking truck arrivals and departures. So the truck systems may be just simply publishing out these messages of when the truck gets to its destination, when it leaves. So all of those things are just published, and I, as the application subscriber, I can subscribe to those messages and then do with them whatever I want. The important thing is this is an immutable log of messages. In other words, you can't change this. Once these messages hit, that is an immutable log of the historical messages. And the other thing about Kafka is that built into the system are things like replication, where you can replicate that information to multiple Kafka servers. So if I lose a Kafka server, I'm fine. The traffic will just go to a running Kafka server. So I don't have to worry about going down. I can have all this stuff, this information replicated, and Kafka will take care of that for me. And because it can shift the load across multiple Kafka servers, I can handle very high message loads. As a subscriber, I can subscribe to as many topics as I want to, as I want to, and as I'm authorized to. So the publisher can decide whether or not I can do it, but then once I'm authorized, I can subscribe to the topics I want. So there can be a many-to-many relationship between these topics and the user. So you can have a user can subscribe to many topics, and there can be many topics there can be many users subscribing to an individual topic. And then with Kafka, there are management systems that are managing all that traffic. So as you can imagine, somebody has to do all the housekeeping to know, well, what was the last message that the order entry system read versus what's the last message that the inventory system read, to make sure that when they go to get a message, they get the next one for them. So there are tools that are part of Kafka that actually do all of that housekeeping and all the management for you. So that's kind of a little bit of the overview of the information. Let's take a look now at actually creating APIs and what does that look like. So if I want to create an API, so I'm going to flip over here to my Visual Studio Code session. Now, for generating APIs with Eradani Connect, we've actually created a Visual Studio Code plugin. For those of you who are paying attention to what IBM is doing, IBM is really starting to push Visual Studio Code as a development environment for IBM users. So we've created a plugin for Visual Studio Code, but everything you're going to see me do here, you could do through the command line if you want to do that. But we've created the plugin here so that you can create things via the plugin. So if I want to create an API to my IBM system, I just need to bring up the Visual Studio Code plugin. Say I want to create an inbound API. Now I'm going to create an inbound API to a table. Let me just go ahead and let me open up a new session here. Oops, hang on one second here.
And Dan, while you're bringing that up, just a couple of quick questions that I think will be easy to answer that have come in. Going back a couple minutes, a question about the JWTs. Are the JWTs encrypted in a quantum safe manner?
So that's a great question.
Aaron answer that.
So that's a great question, and not necessarily a super quick one to answer, but I can summarize pretty quickly. The short answer is, as far as web security goes in the context of a viable quantum computer, JWTs are one of the more secure technologies for you to use. And I say that because when quantum computers become viable, and I do expect that that's a when, not an if, that is going to wreak havoc on the entire security community. Now, there's a couple of attributes of JWTs that make them resistant to an attack by a quantum computer, and that's going to help them remain a viable authentication mechanism when that technology is viable. One is that you can select what the signing algorithm is that you use, and I know that NIST is already investigating the usage of a couple of algorithms. I think I just remember it because I love the name. There's the dilithium algorithm, I think is one of the ones that's under consideration for it. So the first point is that before quantum computers become viable, those algorithms will most likely be available well before that. And you can switch your JWTs to use those signing algorithms that are quantum safe before it becomes a problem. So that's the first piece. That will help out with JWTs. The other piece is that generally speaking, your quantum computing doesn't allow someone just to crack sessions willy-nilly whenever they want. It's something that will reduce the amount of time required to decrypt a session. I've seen varying estimates, but usually they land around 100 days, somewhere around there. You're talking about that kind of time frame, a couple of months to crack a session. The reason that's important and why it's important to use something like JWTs is if I'm using basic authentication with IBM user profiles, someone gets a message from my session, it takes them 100 days to crack it. And if I haven't changed my password by that point, they now have my IBM user profile and password. They can log in, and I have serious problems. With a JWT, you use a temporary key and rotate your signing keys regularly, which means that by the time, even if somebody gets your token, by the time they're able to crack it, the keys will have been replaced. The token is long expired because the tokens usually last about 12 hours. At least that's the most common configuration with Eradani Connect systems. So all that to say, quantum computing is a fairly complex topic, but the general answer is JWTs are going to support what we need in a post-quantum computing world, and they're certainly a much better bet than a lot of the other technologies out there. So I hope that answers the question sufficiently.
Yeah, thanks, Aaron. And two more real quickly before we go on. Is Kafka required to use Eradani Connect?
So quick answer to that, no. Eradani Connect is there to connect your IBM applications to whatever it is that you need to connect to. So Kafka is one option, but it actually all works based on a connector that's installed on the IBM.
Great.
I think that what's really important there is because Eradani Connect actually allows IBM to talk to things like languages like JavaScript, like Node.js, is that the Eradani Connect can talk to Java, it can talk to Kafka natively. So you talk to Eradani Connect, we talk to Kafka. You don't have to try to write something. You don't have to write your own Kafka client. It's already built in. So if you want to connect to Kafka from the IBM, you have to have some way of doing that, and Eradani Connect provides that. But you absolutely don't need to use it if you don't want to.
And you can decide if this question should be answered now or if we want to hold it till later. Doug asks, as we start using more APIs and open the IBM to the public, can Eradani Connect help prevent denial of service attacks? If so, how?
So there's a couple of things there. One is you can use the built-in Eradani Connect modules. There is a rate limiting module that's going to be most useful for that kind of thing because it's going to reject requests that come in at high volume. That being said, what we really recommend is to use industry standards, which is really what this whole thing is all about. Eradani Connect exposes an industry standard interface. It looks like a normal web server. It follows the best practices that basically everybody in the REST API world is using. And what that means is you can use other technologies with it. So my specific recommendation there would be to get a web application firewall. You could use something like Cloudflare is a great company that's specifically designed for this, and they have wonderful support for those standards, and they'll protect you from those kinds of things. So basically you put that up in front of your APIs, and it'll protect you from actually a wide range of attacks. And again, that's really possible because the API system is following those industry standards, and that's why we do it.
Yeah, but out of the box, you can do things like rate limiting. So if suddenly you get an overwhelming number of requests, you can actually say, no, I'm not going to let those in. You can block those addresses. You can say, oh, I just want to block where those things are coming from. So there are a lot of things you can do just out of the box with Eradani Connect to manage it. But yeah, there are industry standard tools that are designed specifically for those kinds of things. And because we're open, you can plug any of those in.
Great, thank you.
So let me just real quick. So I'm going to just give you a quick look at how this works. So I've got a table out here on my IBM. This is kind of the simplest of APIs. So I want to go to this table and do a quick select. So I can go over to the table. Oops, I'm going to go to the workbench here. So I'm back at my Eradani. Oh, actually, that's not the Eradani Connect. Here's my workbench. So here I'm in my workbench, and basically what I can do is I can say I want to create an API, and here's where it's going to be. So this is its sort of endpoint when people call it. It's going to be a get. It's going to be a query, and I'm going to do that same query. And I'm going to just call that customers all. So basically that's it. So I've now said I want to do that, and I just say, go ahead and generate the code. So now Eradani Connect is actually generating the code. Now, when it generates the code, it's generating the routing code to get to that endpoint. It's generating the data transformation codes to transform data from IBM ways of representing data to open source ways of representing data. It's generating all the authentication code to make sure that whoever's doing this has the authority to do that. So it has now generated the code. Now I'm going to go ahead and go ahead and build that code. So let me go ahead and build it. So it's now building the application. So it's basically doing the create of the application. And I can follow the progress of that over here. Okay, so it's done it. Now I'm going to go ahead and start up the API server. So it's done that. And so now I can go over here to my browser session. So I'll bring up my browser, and I can now go into the browser, and let's just go up to that particular endpoint. I've bookmarked it here. So I'm going to go to that customer, API demo / customers endpoint. And here you can see I get the same 3 records, those records that I saw through the green screen. And here I'm seeing it in JSON format. So the system went out, said, go get me the data from this table. It gets it back in IBMI format. It then transforms it into JSON and hands it back. So basically, I created that quick API to do that connection. And now if we take that to a kind of a little bit more, a little higher level, a little more sophisticated level of doing something that's a little more complex. Here I've got a program. So I've got this RPG program. It takes in a couple of parameters as input, and it returns a dimension data structure. And that dimension data structure is multiple levels deep. So it's arrays within arrays. It's got, it's a fairly complex data structure. So I can go ahead and call this now. I can create a call to this particular thing. Now, in order to do the transformations from something like JSON or XML, we need to know all this information about what these fields look like. And to do that, we build this YAML file. So the YAML file actually describes that data, and we're going to use that for the transformations. And I'm going to show you just in a second how you can build that YAML file. But anyway, so we use that for telling us how do you transform from unstructured data into what the IBMI expects. So I'm going to go in and say, okay, go ahead and generate this API. So I do this generative, again, an inbound API. So I'm going to come into the system, and I'm going to call this /API/demo. And this one we'll call orders. So this is for getting orders. Again, it's a get, but this time is for a program. And I'm going to call it get orders. And then I'm going to go ahead and generate that code. So same process as I did before. I went ahead and generated the code. And now that it's generated the code, so now I'm going to go ahead and do the build of that code. Same process here. I do it all right through the workbench. So it's now building that code. And so now I've done that. So now I want to go ahead and run that. So what I'm going to do is start up my API server again here. Go over to my browser. And again, it wouldn't have to do this through the browser. I could do this as an API call from a program, or I could do it from something like Postman. But I'm going to go ahead and do it through the browser here. And again, go to that particular place. So this time I'm going to the API demo orders API. And you see, I get back this very complex looking JSON string. Again, what I got back from the program call was that dimension data structure, the RPG kind of data structure, but it's transformed it now into this JSON format. And notice that I passed in some parameters as part of this. If I hadn't done that, so let's say if I took these parameters off and simply called the API, I would get error data back saying, hey, there's an error here. The customer ID and the order ID, those are both required parameters. I have to have those. So the system is also doing your error handling, where it's passing back error messages if things aren't as they should be. It's also scanning that data to make sure somebody isn't sending in, executable code or trying to send in something that would allow them to attack your system. So built into that Eradani Connect API is code for checking the data to make sure that that data is valid. So you're not, sending alphanumeric data into a numeric field so that you crash your program. So we're going to check that data before it ever gets to the IBMI. So if I go back here now to the JSON, let's take this one step further and assume that, okay, I actually, instead of creating a call into the IBMI, I want to call out to something that actually provides this JSON data structure. So I want to call out to something that provides the JSON data. I can actually go in and say, I'm going to select that data. I'm going to copy that data. So let's just say this is an API where this is what it gives back. This is the JSON that it gives back. And it's, some API running on, a Linux system somewhere. It's not the IBMI data, service we just called. So I'm just going to grab some JSON data. So I've grabbed some JSON data. I'm going to go back to my workbench here. And let me just get some of these things out of the way here. And so now what I'm going to do is I'm going to create now a new file here. And I'm going to call this file get orders.json. So again, assume that you have an API you want to call and you have the sample JSON for that particular API. I'm going to go ahead and paste that in, save that. So I've now saved that JSON data. Now what I'm going to say to Eradani Connect is I'm going to say, Eradani Connect, would you create a map of that data for me? So now it's done that, and here you can see we've got that YAML file that describes the data. So now I can go in and say, okay, now generate for me an RPG program that will call that API. So generate the code that I need in order to call that API. So I can now do what we call an outbound call. That is calling from the IBMI outbound. I'm going to say, go ahead and generate that outbound call, and we'll call it demo.orders.get. And we'll say that's, we'll call the function, the function it's going to build, we'll call it get orders. And we'll call the RPG program it's going to create, we'll call it get ord RPG, and then we'll generate that code. So basically now it's generating the code to do that, and it's generating a whole lot of stuff. It's generating the RPG code to call it. It's generating the JavaScript code that will actually do the API secure handshake, do the API call, get the data, and then transform the data back for the IBMI. So it's done that now, and I can actually go in and look and see, okay, I've got this RPG program that it created, that it generated. And the important part of this RPG program that it created is this line right here, which says, execute an Eradani Connect send request to call that API. So basically, this is code you could just include in your RPG program if you want this to happen in a particular place in your process, but it's generated the code necessary to call that API. So basically, that's generating the RPG code, the JavaScript code that you need in order to call the API. Now, you can customize this. It's just standard RPG. It's standard JavaScript. You can customize those things if you want to do that. So I know I just went through a whole bunch of things. Any questions on that? What I've covered so far.
So that's a good pause point. Please, if you have any more questions, type them into the Q&A section. We'll get those answered for you. And Dan, we have about 8 minutes left,
right?
Just to give you a time check.
Right. So yeah. So I'm going to move on to just some of the management stuff, just to finish up. If we don't have any questions at this point.
One question. Hey, Doug Peterson, shameless plug. I'm an Eradani customer. Highly recommend their software support and services. Aaron is great to work with. Moreover, Aaron is extremely knowledgeable, helpful, and patient. We have several APIs built through Eradani and have plans for dozens more.
Well, Doug, I love working with you too.
I was just going to say that kind of question is always appreciated. So we'll take the shameless plugs any day. Thanks, Doug. And Ralph, you're welcome. Thanks for joining us. Any other questions that we can answer? And as they come up, just shoot them into the chat. All right, I'll let you guys wrap it up.
Okay, terrific. So just a couple other things on management. So here you can see this is a sample of the management dashboard, that you can use for actually manage. Hang on for a second. All right, it doesn't seem to want to go to where I'm going. So here's a sample of the management dashboard you can use, where you can track all the API traffic that's coming in. So you can keep track of who's calling you, what kind of response time are they getting, how much CPU is being used. You can go to every single API endpoint and see how each API is performing. You can go into the errors and see what the errors are that are coming in. So you can track all the errors that are coming in and drill into the errors. So there's lots of information here for you for managing the API traffic that's coming into your system. And then you can also manage your development if you want to. You can manage your development using the latest open source kinds of development tools. So if you want to use something like Git, for example, for managing your development, you can do that. So let me just give you a sort of a sample of what that looks like. I'm going to go over back here to my web browser. So here you can see I've got an environment where I'm managing what looks like IBM code in Git. So this is GitHub, but this could be, GitLab, it could be Bitbucket, it could be your own Git repository in your IBM, so whatever you want. But you can manage all the development that you're doing using these modern tools. So if you want to use Git, you can do that. And so here I am managing things inside of a Git repository. And so if I want to, I can go back and look at the history of changes that have been made to these files. So for example, I can go in here to QRPGLE source and open up this program, and I can see, okay, here's the source code for that program, but I want to see who's made changes to this program. And so here I can go in, I hit what's called the blame button, and I can go and see for every line of code that was changed, who changed it, why they changed it, when they changed it. So I've got all this information. And I can go back in history. So, it's not like putting a little comment in a line of code to say this line of code was changed for this project or something like that, which if you then work on a new project, you lose that documentation. Here I can go back through history and I can say, well, show me the last change, and then show me the change before that and the change before that. So I get all of this history of change. And I can go into if I want to, I can go to the history of each time a developer has said, I'm done with the set of changes, I'm going to commit a whole bunch of changes together. I can go in and look and see, okay, well, here are all the commits that the developers have done. And I can say, well, when they committed that set of changes, what was changed? So for that particular thing, they changed a physical file, and here's the change they made. They changed an RPG program, and here's the change they made. They changed a SQL table, and here's the change they made. So I can see all of that information, and I can do all of that with my IBM code and my open source code. So if I'm doing JavaScript development and IBM development together, I can see all of that in one repository. And again, we have another presentation that goes into a real sort of deep dive around all of this, but I can access these tools. I can access Git from PDM, so I can get it right at it from a PDM session. I can get at it through, so if we go in here to RDI, I can go into RDI and I can make changes directly in RDI, and I have access to all of the Git functions, the commits, the adds, the pulls and push, all the things that you do in Git, I can do right here on my IBM code right directly through RDI. So again, through PDM, through the green screen, through RDI. So basically, the idea here is that the Central Integration Hub provides you with a way of managing everything that you're doing, regardless of whether it's IBM code or whether it's new code, and that it integrates into this whole idea of having that central integration hub, where you have that one place that you go to manage everything that's happening. So you create your APIs here, Once you create the APIs, they provide the security, they provide the data transformation, they provide the connectivity, and they provide you a way of managing all of this communication, regardless of which of these use cases you might be using for talking to your IBMI. So the idea is you have the central place where everything's coming in so you can manage all of it in one place. So that's basically, I know it's a ton of stuff that we covered today. I will leave it open to the last couple of minutes for any last questions that people have. Mike, you see anything else coming in?
I'm looking, nope, nothing so far. I think that's it, Dan.
Terrific.
So thank you. Thank you, Aaron. Thank you, Dan. Thank you, Brittany, for putting this together with us. Very much appreciated. The recording will be sent out. It will probably go out Friday morning to you guys. And if you have any questions, whenever you get an email from Eradani, it's usually from me. You can just hit reply. It goes right back to my inbox, and I'll make sure the questions get answered. So thank you, everybody. Hope you enjoyed the session and have a great rest of your day.
Thanks, everybody.
Thank you so much, everyone.
Bye-bye.
Bye.